Question number 29. Two lines X and Y in the emission spectrum of hydrogen gas are measured by an observer stationary with respect to the gas sample. Okay, so what is he asking here? You have hydrogen gas. In hydrogen gas, you have X and Y lines of increasing wavelength which are measured. Okay, where stationary observer? Stationary observer, whenever you say stationary observer, which means what are you talking about? You are definitely talking about a Doppler effect. Okay, the emission spectrum is then measured by an observer moving away from the gas sample. When you move away from the gas sample, and that you are talking about spectra, then what is the Doppler effect formula? Delta F by F is equal to V by C. Now let me consider that V by C is equal to some 0.1. Okay, so therefore delta F should be equal to 0.1 times F here, right? Okay, now we know V is equal to F lambda, or delta V is not changing, so delta F by F is equal to delta lambda by lambda, relative uncertainty method, okay, which we have got this here. Okay, or if you're still getting confused, do ask me. I'll just put across a video, or maybe you can go to my website to see how do I get these kinds of things. Okay, or maybe I can put it here also. F is equal to V by lambda. This might be more clearer to you, and thus I can say delta F by F is equal to delta lambda by lambda, because velocity is constant. Okay, I hope now you have got this. Okay, now if that is the case, now I'll replace this one by lambda, because I have everything in terms of lambda here. So therefore I will write delta lambda by lambda is equal to 0.1, or delta lambda is equal to 0.1 times lambda. Okay, or lambda 2 should be equal to lambda 1 plus 0.1 times the value of lambda, the initial value of lambda. Now what I will do is, let me consider something like lambda is equal to some lambda 1 is equal to 400. Okay, because in your hydrogen spectra you get 400 to 700, right? So first one I'll do lambda 2 should be equal to 400 plus 0.1 times 400 should be 40. So how much do you get? 440 over here. Okay, now another wavelength, what I'll do is I'll consider lambda 1 should be equal to around 600. So when I take 600, this will be 600 plus 60, 0.1 times, so which should now be equal to 660 over here. Now what's happening? When the value of lambda is lesser, the shift is also only 40. When the value of lambda is higher, the shift is also increased more over here. It has become 1.5 times here. Now let us look at this pattern here. See here what's happening. This is the original line. The shift is backwards over here. This is not possible, right? It means if this is 400, this could have been 380. Okay, this is not possible. Now let us look at this. If this is 400, this could have been something like 300. This is also not possible. Let us look at this here. If this is 400, this should be 440. Agreed. Now let us look at this. This is 600. This can be 660. See, the width here is larger here as compared to this width. That's what is expected here, right? Now let me, so therefore C should definitely be the right answer. Let us look at this here. If this is 400, then what is this now? This is larger as compared to this. See, if this is 40 units, this 60 units should be much larger over here. Okay, but what is in here? It's much smaller over here, which means that this should be only 20 units over here, which is not seen. So therefore C is the right answer. All the other options are incorrect.